Welcome to the deep dive. Today, we're looking at something really interesting. A regional airline making a proactive leap towards electric propulsion for their short-haul flights.
Yeah, and we've got a good amount of source material here showing the core problem they faced. It wasn't just one thing, was it?
No, it was like this convergence, growing pressure to cut carbon emissions,
Yeah.
regulations getting tighter, fuel costs going up, and at the same time, passengers increasingly wanting greener options.
Exactly. A perfect storm,
Yes.
almost. And their response wasn't just reactive. They went out and forged a partnership with an aerospace startup. The goal, integrate electric aircraft right into their fleet.
Okay, so let's unpack this because, as you know, swapping jet fuel for batteries isn't simple. Our sources really highlight some, significant hurdles.
Big ones.
Yeah, like the limitations of current battery tech, especially range, how far can these things actually fly?
Hmm.
Then there's the almost total lack of charging infrastructure at airports, right now.
A huge practical problem.
And then, of course, navigating the complex world of aviation regulations. So the mission for this deep dive is really to understand how this airline is tackling each of these challenges.
And what it might mean for the future of regional air travel overall.
Exactly.
And their first step seems pretty smart. A really thorough assessment of the core technology of the batteries.
Right. Not just looking at what's available now, like lithium ion.
Although they definitely did that. But also exploring, what's coming down the pike.
Yeah.
Things like solid-state batteries, even hybrid systems.
And this wasn't just a superficial look, was it? The material emphasizes these critical performance factors they had to weigh up.
Absolutely key factors. Energy density, for one.
Which is basically how much juice you can pack in affects the range.
Exactly. Then the weight-to-power ratio, always critical in aircraft design. Every ounce counts.
Mm-hmm.
How many charge cycles they can handle before degrading too much. And, of course, safety. Safety above all.
That weight issue is fascinating. You could have an amazing battery, but if it's too heavy?
It kills efficiency. It's a non-starter. What's interesting here is they didn't just evaluate current tech. They also got involved in research collaborations.
You're looking ahead.
Yeah, trying to stay ahead of the curve on future battery developments. Thinking about the planes of tomorrow, not just today.
And beyond the tech itself.
Well, the practicalities, supply chains, who can actually make these high-spec aviation-grade batteries reliably and at scale.
Right, you need a steady supply. Okay, so they're figuring out the batteries. But flying is heavily regulated for very good reason. How did they handle that side?
Yeah, regulatory compliance and certification were absolutely central. They knew they couldn't just build a plane and fly it.
No way.
So their proactive engagement with authorities like the FAA and EASA right from the start, that was key.
So talking to them early on.
Very early. And it wasn't just informing them. Our sources suggest they were actually kind of helping develop the certification frameworks for electric aircraft based on their own safety models and testing.
Wow, so not just waiting for the rules, but helping shape them. That's insightful.
It really is. And the safety testing they undertook sounds incredibly rigorous.
What kind of things?
Well, detailed analysis of battery failure modes, fire resistance testing, even looking at potential electromagnetic interference with the aircraft systems. Things you really need to nail down.
Absolutely critical. You can't cut corners there.
No. And their goal wasn't just to meet existing safety standards for, traditional planes. It was to meet or even exceed them with electric aircraft.
Setting a high bar.
Exactly.
Yeah.
And by doing that, by contributing to these new industry standards, they're not just helping themselves, they're paving the way for broader adoption.
Okay, so planes are progressing, regulators are involved, but where do these things plug in? Our sources clearly flag the lack of charging infrastructure as a massive roadblock.
It is. It's a major bottleneck.
Yeah.
Think about EVs on the road, but scale that up for airports.
Right.
So the airline knew this. They started collaborating early with airport authorities, with energy providers.
What did that involve?
Well, planning for installing fast charging stations at their main regional hubs. That's crucial for quick turnarounds.
Can't have planes sitting charging for hours.
Exactly. And also assessing, can the airport's existing electrical grid even handle that kind of power draw? That's a big question.
Huge logistical challenge. Were they looking at other ways to keep them powered up?
They were, yeah. Exploring some pretty innovative alternatives.
Like what?
Things like battery swapping technology. So instead of plugging in, you quickly swap out a depleted battery pack for a fresh one.
Ah, interesting. Minimizes ground time.
Potentially, yes.
Mm-hmm.
And also looking at generating their own renewable energy right there at the airport, solar, maybe wind.
Right, makes the whole operation greener, not just the flight itself.
Exactly. Closing the loop, so to speak.
Okay, so infrastructure is being addressed. Now, what about the pilots? Flying an electric plane, I assume, isn't quite the same?
It requires some adaptation, definitely. So the airline invested significantly in specialized training programs.
Focusing on what?
Things like advanced battery management, really understanding energy levels, how to optimize usage in flight for maximum range.
Makes sense.
Also, specific energy-efficient flying techniques tailored to electric propulsion. And, of course, emergency procedures related to the electric systems.
And they use simulators for this.
Oh, yeah. High-fidelity simulators. To make the training as realistic as possible, get the crews comfortable and proficient before they ever flew the real thing.
And presumably the maintenance crews needed new skills too.
Absolutely. Specialized training for them on diagnostics, safety procedures for handling high-voltage systems. It's a whole ecosystem that needs retraining.
Right, it touches everyone. Now let's talk the bottom line. All this innovation costs money. How did they justify it economically?
Well, they did a very comprehensive financial analysis, comparing the projected costs of electric operations versus sticking with traditional fuel-burning aircraft.
What were the key variables there?
Expected maintenance savings. For one, our sources highlight that electric motors have far fewer moving parts than jet engines,
Which should mean lower maintenance costs.
significantly lower, potentially. Then there's the cost of electricity versus volatile jet fuel prices.
That's a big one. Fuel prices are notoriously unpredictable.
Exactly. So electric offers potential for much more stable, predictable energy costs long term. Plus, they looked into potential government incentives, grants for green projects, maybe carbon credits down the line.
So it wasn't just about being green, it was potentially a financially smarter move too in the long run.
That was the argument, yes. But, theory is one thing. They needed data. How did they validate all these assumptions?
Good question.
Through rigorous testing. Extensive ground tests, extensive flight tests on the prototypes,
What were they measuring?
key performance indicators,
Mhm.
energy consumption rates in different flight phases, battery degradation over many cycles, power efficiency in different weather conditions. The works.
And did the tests back up the theory?
It seems so, yes.
Yeah.
The data apparently showed that electric aircraft could operate efficiently on their target short-haul routes.
That's promising.
Yeah, and they used real-time telemetry data during tests. That allowed them to constantly tweak battery management systems, optimize energy distribution. It's a continuous improvement loop.
And this data wasn't just for internal use, right? It fed back into the regulatory process.
Absolutely crucial.
Yeah.
They weren't just asking for approval. They were providing the regulators with substantial empirical data performance, safety, everything from their tests.
That transparency must have helped.
Immensely. It fostered a collaborative approach, helped streamline the approvals, and by sharing this data, sharing their experiences, they're contributing to, industry-wide best practices for electric flight.
Okay, so technically sound, regulators getting comfortable. What about passengers? Would people actually want to fly on an electric plane?
They researched that thoroughly. Market surveys, focus groups. The findings were pretty positive, actually. Significant consumer interest in sustainable travel. Many people said they'd be willing to choose an electric flight.
Even with potential minor inconveniences.
It seems so. There was a demonstrated willingness, especially among certain groups.
Which groups were most interested?
The research pointed particularly towards business travelers and, perhaps unsurprisingly, environmentally conscious consumers. They showed the highest likelihood of actively choosing electric options.
Okay, so that validates the strategy from a market perspective too.
True.
Right, let's get to the results then. After all this effort, the research, the partnerships, the testing, what did this airline actually achieve?
Well, the outcomes look pretty compelling based on our sources. Significant reductions in fuel-related expenses.
Which boosts financial sustainability.
Directly. And less reliance on aviation fuel means insulation from those price shocks we mentioned.
And missions.
They didn't just meet the government targets, they apparently exceeded them, and ahead of schedule.
That's a big win. Sends a strong message.
Definitely enhances their brand reputation, helps attract those eco-conscious travelers we talked about, and also boosts investor confidence.
And puts them in a good position for future regulations too, presumably.
Much better positioned. Being ahead of the curve means smoother compliance down the road, as rules likely get even stricter.
It sounds like this whole initiative also opened doors for them.
It did, yeah. Being an early mover in this space allowed them to secure strategic partnerships.
With who?
Key players across the electric aviation ecosystem, battery developers, aircraft manufacturers, energy providers,
Yeah.
the whole network.
Giving them a competitive
A
edge.
real competitive advantage, yeah.
Mhm.
And it let them influence industry trends, solidify their position as a leader in sustainable aviation. They really established themselves as a model for others to follow.
Okay, so if we boil it all down, what are the main takeaways from this deep dive?
I think the biggest one is the power of being proactive and comprehensive.
Yeah.
This airline didn't just dip a toe in, they committed fully.
Right.
They faced these huge environmental and economic pressures and saw transformative technology not just as a challenge, but as the solution. And they tackled the hurdles, tech, regulatory, infrastructure systematically, research, partnerships, innovation.
And the impact goes beyond just this one airline, doesn't it?
Oh, absolutely. This case study is like a practical blueprint. It shows how commitment to sustainability can drive real innovation and lead to a more resilient business.
Mm-hmm.
It really adds to the momentum for greener air travel overall. Shows that these big, tough challenges can be tackled with bold thinking, good partnerships, and, well, a willingness to embrace the new.
It really makes you think, doesn't it? Consider what this means for other industries facing similar sustainability pressures. What other big, maybe seemingly intractable problems could be cracked open with this kind of bold collaboration and tech adoption? Definitely something to mull over. Thanks for taking this deep dive with me today.